All right, it's noon, so we'll get started. Today's talk is going to be presented by Todd Sears. Todd is a Homeland Security Planner with the Division of Emergency Management Homeland Security, which is a division of the Department of Public Safety for Vermont. And he's going to be talking about critical infrastructure. So I will go ahead and hand it over to Todd.
Thank you very much, Zach. I want to preface anything that I say with a couple of things, actually. One, I'm sitting in here with a bunch of planners and engineers, and I just want to let you all know that I studied philosophy. So please be kind and keep that in the back of your mind as you ask your questions and stump the dummy. Number one. And two, I'm really delighted to be here. I've been up here a few times working with Jim on some things, and I know Zach from before, working in Homeland Security and emergency management, and I'm really happy. And it's turning into a good weekend. My son Alexander, who's sitting right here, he's a outdoor education major at Johnson, and he came over here, and we're going to Tiny Tie after this. And I'm running a cool mountain race tomorrow, so things are setting up for a really good
world class.
Yeah. So I totally expect to fall tomorrow at about mile 7, right on my face. Okay, so one of the things I wanted to do is Zach calls me up when he asks me to put this thing together, and he says, "Hey man, you said you were going to do this, but I need a topic. I had no idea really what that was, so I made up this thing. I said, do this. Talk about broad spectrum domain awareness. Let's use that. So I thought I'd lead with the most pretentious and jargonistic buzzword set of words, which buzz as I could. But what that really means is this in emergency management. We need to know a lot of things when the balloon goes up, and that's a really hard challenge in the critical infrastructure world. And what I hope to do is kind of explain why that is, because it is really kind of challenging. So that's what I want to do. These are my objectives. I'm a retired military guy. I am absolutely incapable of having a normal conversation without PowerPoint. So if this crashes, I'm done. Objectives, right? So I want to familiarize you with some of the terms, the lexicon that we use in the critical infrastructure world. Talk about the centrality of this data in the midst of in emergency response operations, why it's important. And then entertain questions. And I say fire at will because when Zach told me to do this thing, he said usually the way that they play out is you talk for 20, 25 minutes and then you answer questions till whenever, and that's fine. Please don't wait to ask questions. Just go ahead and fire at will if you have any. If not, no sweat. All right. Are most of you TRC folks? Anybody from outside of the TRC Research Center? Okay, so it's all good.
From various disciplines, though.
Various disciplines, and I understand it's a multidisciplinary thing. Nobody from upstairs from the Center for Complexity Analysis?
No.
That was a huge fear of mine. Because what we're talking about, really, when we look at critical infrastructure, it is, no lie, it's a complex system in a lot of different ways. And so I'm very interested in, at some point, as I kind of get more mature in my thinking and our thinking, on how to approach this at a state level, to engage with those guys upstairs and talk about some modeling and simulation and those kinds of things. And Zach gave me some hints as to how to approach them and do that. But I have looked at some of their work, and I think it's, in fact, the UVM TEDx from 2011, 2012, I got to review some of those videos, and I thought that they were good, and there were some points of congruence there that, I don't know, maybe there's value added. I kind of wanted to start, though, this with, because I didn't know if there were going to be like locals that came in, like EMDs that really hadn't thought. So this may be kindergarten level for you, but I'm going to go through it because I can't get out of sequence with the slides. Let's talk about critical infrastructure. What is it? When I say that to you, what do you think about? What's critical infrastructure? Critical infrastructure. What do you think?
Bridges.
Bridges is one. So bridges is a good example of a subsector of one of the 16 sectors of critical infrastructure. So bridges is actually, you're right, is actually a subsector. Other things?
Transmission lines.
For what?
Electricity.
What else?
Transmission pipes for natural gas.
Natural gas, so you have energy. and then you have energy, and then you have electricity as a subsector of energy, and a subsector. This taxonomy that they use is absolutely Byzantine, but it's there. So you have transmission and distribution lines for gas and for electricity, and so that's a piece of it too. What else, Jim?
I think of like the ownership, like public infrastructure seems like a much more challenging.
Okay.
Because something that's private, they can kind of manage in times of
Yeah.
problems, whereas like public infrastructure is just kind of chaos.
So stuff like the public works guys use, water, wastewater,
Yeah.
for example,
Yeah.
that is a specific, its own sector, the water and wastewater sector. Yeah, so there's a lot of it. So what I'm going to do is I have like 16 slides that just run through what the critical infrastructure is. There are 16 sectors, as I talked about, and these 16 sectors come from what's called the NIP, the National National Infrastructure Protection Plan, right? And so we use the same taxonomy here in Vermont as we look at the way that critical infrastructure works. So what is it? I'll just step through. The definition first, of course. That's our definition, again derived from the national definition, but what's important to take away from this is this. Asset system, etc. Physical and virtual, because cyber is a piece of this. It's a critical piece of this. So vital to our state that their incapacitation would have a debilitating effect on security, etc. Would have a debilitating effect. So what this is based upon is a consequence-based analysis of our pieces of infrastructure. We have to be thinking about if something happens here, or this event happens to facility X, what are the follow-on cascading effects that we could possibly see? And we have to sort of measure that. We have to come up with metrics. And this is very difficult to find these thresholds of consequence, because we're actually talking in terms of how many people could die, how many people could be displaced, how many pieces of the healthcare system could be taken out of play so people couldn't get care. Consequence-based. Well, consequences, by definition, they haven't happened yet, so we sort of have to what-if this stuff. And that's part of the challenge. And when you're dealing with us at the state level like this, one of the huge muscle movements of this program is to get together with each of the sector subject matter experts, and this is kind of the stage that I'm in now, and say, okay, what is the level of criticality? What is that threshold for consequence? And then you get into questions like, what's the number of prompt fatalities where if it's under that, it's not critical, and if it's over that, it is critical? These are sensitive questions, and so it takes gentle engagement with subject matter experts to try to answer those. Some of the sectors of infrastructure, they're already answered. Dams, for example. Dams are classified, and there are certain criteria that are already set to say these are high hazard dams and these are not. Well, in Vermont, our critical dams are the federally declared high hazard dams. So that's good for me because the criteria are already defined. I'm good to go with that. It's some of the other ones that are a bit more problematic. So the 16 sectors, I'm just going to run through them. One of them, I'm pretty sure you got your arms around this one. But important to kind of break out that transportation is the sector, and then you have subsectors underneath, and it's rail, air, maritime, road. In Vermont, I think most of the analytic effort and concern out of the agency, I think, is probably more geared toward road. There's more miles of it, and a lot of people use it. But so transportation is one of them. Water, wastewater, which we discussed. Reservoirs, transmission, distribution, wastewater, how it's cleaned and kind of recycled back into the system. Emergency services, this is a big one. A lot of stuff happening in here. So you have law enforcement, emergency medical, emergency management, sheltering, public communication, so your 911, all of that, all happens within this emergency services sector. Communications, you'll see another one later on, information technology. Don't try to discriminate between those two in your head, because I can't even explain it to you. Those are kind of fused together, information technology and communications. Energy, which we talked about already. So solar energy, any number, fuel, electrical energy, nuclear. So VY, the nuclear generation, is a piece of it. But then you also have like medical waste issues and medical. So strontium-90, cesium-137, cobalt-60, little small amounts. We're concerned about that kind of stuff, not because it generates energy or anything like that, but it's out there. And if bad people got a hold of something like that, you know, you're talking about potential for a radiological dispersion device, a dirty bomb, an RDD. You know, so we are concerned about where that is, how that travels. Banking and finance, very cyber dependent. Food and agriculture, absolutely huge. I don't know if Jim has talked to you at all about the proposal that we put together, the Regional Resiliency Assessment proposal. But we worked together, DMHS, TRC, Department of Ag. I've talked to some agricultural co-ops kind of in the private sector, VTrans. And we're looking at, we put in a proposal to have a DHS-funded study that looks at our dairy sector specifically, but beyond that, the lines of communication within the dairy sector that sort of describe how milk gets from where it's generated, where it's shipped, treated, and then created into some kind of retail product. And so that gives you an idea of interdependencies and how these sectors overlap, because they do. And we'll talk a little bit about these interdependencies later. But food and ag is a huge one. Craft beer, very important. Chemical, that's its own subsector. This is another one that's pretty easy to, well, none of this stuff is like easy, but chemical is one where there's a gradation of significant chemicals, and so we can kind of use that to drive how we define our sectors, sort of like dams. Government facilities, just what it says. Commercial facilities. Critical manufacturing. So those two, critical manufacturing, commercial facilities, huge economic component to that, because that's how you're going to measure criticality there in some kind of economic calculus. I was just meeting with an economist, Ken Jones, that works over in our Office of Economic Development to try to generate and sort of brainstorm some of these metrics we might be able to use to define what makes a manufacturer critical, commercial facility critical, and whatnot.
Don't share the list of who doesn't make the cut.
Well, that's a great point. That's a great point. And that gets into like the sensitivity of this information. Once we have all of this stuff compiled, it's public information. A lot of it is. I can tell you that what's determined to be critical is probably going to kind of be out there. What's not going to be out there, what we will protect, is sort of in the long game. Once we have the list generated, we want to go out and do vulnerability assessments. So we go out to a particular place and we can see what's good, what's bad, where it's vulnerable. We're not going to publicize that. That we will protect. But the list itself, what's critical, what's not, probably going to be out there, and you do have to deal with questions like that. Well, why didn't we make the cut? We're good, you know. We have to figure out how to deal with that. It's one of the challenges. Defense industrial, we don't do a lot in Vermont with that. IT mentioned it already. Healthcare, acute care hospitals, other things, clinics. And then finally dams. And I'm going to sort of step you through a dam scenario later on to describe and show you why this stuff is important. So those are the 16 sectors. Any questions on any of those? There are probably a lot of questions like roiling around in your mind because it can get fairly complex. So those are the individual sectors, but in the critical infrastructure world, we don't think about things, pardons for the eye chart, but we don't think about things by sector necessarily. At the beginning we do. It's very easy to think about how we assess and develop metrics per sector, but really, when it comes to consequences, you've got to be looking at the fact that these are interdependent systems. And if I take out a particular electrical substation or a step-down transformer or something like that, that could have profound effects on downstream capabilities. And this kind of gives you an idea. If you take electrical power out, it could affect the ability to pump oil, to pump water, telecommunications, so electricity itself, but our ability to use the internet, our ability to to use the internet within a utility to affect and power up SCADA systems. You know what SCADA systems are? Pretty familiar with those industrial control systems? It's trons that actually move hardware. So dam gates, and it reads meters, and it looks at meters, takes those readings, and then if it is of a certain level, it does something industrially within the plant. All of that stuff would be affected if the internet somehow were taken out. So not going to spend all too much time there, just to make the point that when I say it's a complex system, I kind of don't look at CI in a sector-by-sector way. I mean, I do, but I understand there are 16 sectors there, but I really look at it as this weird tapestry of all of these sectors that are interconnected with bits of thread, and the challenge is to really figure out how that all works, and you can only take that to a certain level. You're never going to know everything about a system like this. Okay, I just want to talk through this little thing. This is the only bit of math here, which pleases me. But this is the risk calculus. When we talk about risk in critical infrastructure, we're talking about risk as a function of 3 primary variables: threat, vulnerability, and consequence. Threat is a slightly nuanced bit of business, because threat, think about it as an external agency. So there can be an intentional threat, which is a criminal, a terrorist that wants to do bad things to this place. Right? That's an intentional threat. But then in Vermont, I mean, that stuff is out there, but in Vermont, that's not what we're looking at as our high probability, high impact event. We're looking at weather primarily, and weather is technically a hazard. It's this non-intentional agency. So that's what threat means. So intentional and non-intentional is a good way to think about that. Vulnerability, the way that we think about it, is a function of the facility itself. It's a function of the thing that we're actually looking at. If it's a site, if I'm looking at the vulnerability of this building, I might want to look at whether it has physical security patrols, fences, cameras, and then how that information is processed. I might want to look at how it has a emergency preparedness plan and how often it's executed and all of that. So that's vulnerability. And then consequence we already talked about, and that is what happens if. What's the consequence if this is taken out or affected? What are the downstream consequences of that? And that's probably the most challenging piece of it. So that's it. We spent a lot of time talking about risk the last time I was here with a smaller group. That's not the focus of today. We can talk about it if you want, but here we are. All right. Is there a question? No? So I want to shift from that baseline stuff and now talk about what I think is the crux of what I want to impart to you today. And that is the imminence of critical infrastructure data in an emergency situation, in an emergency environment. So if something bad has happened, or we anticipate that something bad is going to happen, how do we use critical infrastructure data to get ahead of it and then use that information to drive stuff actually happening on the ground, which is what we do in the emergency management, where we plan and we operate. The place we do this in Vermont is called the SEOC. It's the State Emergency Operations Center. It is in Waterbury, Vermont. That's a picture of it. You helped design that?
No.
Oh, okay. Good for
Sure.
you.
Yeah.
Good for you. No, you don't want to
I won't take responsibility for that.
Yeah, but it's a place where a lot of people sit, and there are a lot of big screens, and there are speakers there. But this is where the decision makers sit. The governor will come here from time to time in the midst of an emergency. Did that during Irene quite a bit, as I understand. And the decision makers, so the EOC manager, agency heads, the governor would kind of sit on this table here, and then you have representatives called state support functions, but representatives from each of the key agencies throughout the state would sit in these tables here, and you don't see 2 other rooms down here. So we have planning section here, that's where I work, and we have operations section down here. It's quite a big footprint, but the bottom line is this is really where, when things happen on a statewide level, people come to learn and to know and to be informed and to make decisions. So, what does it do? I kind of look at it in an operations and an analytic dichotomy there. So operations, translating guidance, like from the governor, for example, into the operational priorities. That's one of the things that happens here. Tracking resources. So, and I'm going to step you through a scenario, but tracking resources. If I have an urban search and rescue team that I have at the ready in Colchester, for example, which we do, it's one of our task forces up there, and we have a building that is about to come down, that USAR team is deployed down to shore up that building, rescue people, do the things that it's chartered to do. That's a resource management kind of problem where we need to be able to look at where they are they unseen, do I have good communications with them, how long are you going to be there, when do you expect to be ready for us to redeploy you to the next kind of site. So this is an operational resource management type of problem set. Managing and sharing information, you can imagine, and I'll talk about it down here when I talk about the common operational picture, management and sharing information is absolutely huge. It's chaotic. It's absolutely, he's been in there, I've been in there, it's chaotic in there, and there's a lot of just horizontal communication from one agency to another to try to sort of figure out what's going on and what to do next. So that all happens here. And then to support the ICs. The ICs in this context, incident commanders. So those are the people that are out in the towns or wherever the badness is happening, that are on the scene dealing with the problem. So it's your fire chief, it's your police chief, your emergency management director maybe in some cases, on the ground there and actually managing the tactical situation. The job here is to be aware of all of that and to support those guys and gals with whatever they need. So we're going to do what we need to do to get them the things that they say they need. If they need fresh bottled water because their water supply is sullied, we're going to try to do that. If they need food because they've been without power for 6 days and everything in the grocery store is spoiled, and they need meat, or we'll maybe get the guard. So the guard can drop off MREs off of an H60. These kinds of things. We're supporting the ICs. So that's an operations piece, and the analytic piece is hugely important. So there's this thing called the common operational picture. And the word picture, I have this debate with colleagues all the time about the COP. We just call it the COP. It's the common operational picture. And I don't know, in my experience, I've worked in a lot of operation centers in my career, not in emergency response, a little bit of that, but mostly sort of in military operations. But it's operation centers are operation centers. They all work, they achieve a mission. And I know how crisis decision-making works. I've been on that side of it, and I've seen it happen. And I know that people, again, at least in my experience, respond to pictures. They respond to graphics. They don't respond as well in this kind of situation to a narrative. So we have the debate, are we talking about a common operational picture or a common operational paragraph? And one of the things I'm trying to do and socialize, and that's one of the reasons I wanted to talk about this specifically here, is to sort of change the paradigm away from the narrative and more toward big pictures up on screens that decision makers can point to and make prudent decisions. Because we probably need to make some improvements in that area, and so that's kind of what we're trying to do. So the common operational picture, analytic piece, and to build that, we need information from all over the place. We just need a ton of information. Imagine those 16 sectors and all of the moving parts that could happen with those 16 sectors. How do we get that into this building, into this operations center, up on a screen to make use of it in a crisis situation? That's part of the challenge. We want to be able to fuse, look at our analysis of hazard effects and the dependencies, again, relating to those the interdependency things piece that I talked about. Horizontal integration and information flow. We want to be able to get all of this chaos that's happening in and amongst the other state agencies that are playing here and actually capture it and make use of it, make it coherent so that once an hour somebody can sit up here in front of a screen and say, here's what's going on to the best of our knowledge, here's what was going on an hour ago, these are the updates, these are the current operations, this is where they are, this is when they're going to be done, this is where we need to go next. So it's kind of just basic planning stuff. And that's something that every emergency operations center in every state can do better. Horizontal integration and get that flow of information better. And then just provide an information platform. And all I'm saying there is, it's just a rehash of what I've just said. Let's keep it at that. All right. It's colorful. It's nice. So this is the operational schedule. This is how we operate. But I just put this up here. Call this our battle rhythm. This is a battle rhythm in an operations center. And the reason I wanted to show it to you is to show you that the way that we do business, once we're stood up, once we're activated, and something bad is happening, and we're responding to it, and we expect to respond to it over a matter of days, we have a cycle. We have a routine. This is a 12-hour routine, so we're kind of port and starboard, 12 hours on, 12 hours off. But you can see here that a situation update kind of begins the day. And briefings happen all throughout the day, and certain things happen, they hit their marks. It's all part of a cycle. But that situation update is critical. We actually do that more now than just the one time where it says here. Talked about horizontal integration. All this is supposed to do is demonstrate that you have a bunch of different agencies, so these are sectors, and these are 5 of them. We want to be able to look at all 16, what's happening, pull it in, visualize it, use it to be able to respond to emergency operations. Okay, so that stuff's done. Now I want to just show you pictures after this bullet slide. I want to set up a little scenario for you. And again, this is a scenario. I'm going to talk about the Waterbury Dam, possibly degraded. That's absolutely notional. It's perfectly fine. Don't worry about the Waterbury Dam. But for the purposes of this, it may be degraded. It's Memorial Day, we have saturated ground, thunderstorms coming, flash floods are already out there, 6 inches expected in that Winooski Route 2 corridor, and we know that the Waterbury Dam had been somehow, we don't know how, but it's degraded. There's a material degradation in that dam. So, being good emergency management planners, we want to anticipate things that could happen. And so, what do I want to look at? What am I worried about with the degraded material condition of a dam? What kinds of things come to mind?
What's it going to affect if it fails?
Okay, thank you. Right, what's it going to affect if it fails? So the Waterbury Dam is a high hazard dam, and we have an emergency action plan for that dam. We also have inundation maps for the Waterbury Dam. Those are maps that are overlays that demonstrate what would happen if that dam were to fail, and it's really nasty. This particular dam is really, really nasty. So I'm going to step through. Okay, we'll start with our God's eye view of the world, centered on the United States, of course. There's the U.S., and Vermont is up here. Here's Vermont, and I got to tell you, the only reason I use this, I love this because it looks like J.R.R. Tolkien did this map. Anyway, so there's Vermont. But then what I want to do is, I know dams are one of my sectors. So being a prudent emergency manager, I have asked our GIS folks to create a layer to just plot out where those dams are. All right, so this isn't just high hazard dams. It's more than just the high hazard dams. But those are our dams plotted out. This is just on the Esri GIS engine. So I've got that. That's pretty good. I'm not going to do really all that much with that, but it's good to know that I got all of those things out there. Drilling down, I'm now in Washington County. I've still got my dam plot, my dam layer that is right up there. More useful, but not where I need to be. Now I'm drilling down into the Waterbury Dam specifically. So here's the reservoir, there's the dam itself, and that's good to know. It gives me an idea of kind of the contours there. The 3D is very nice. It gives me an idea of the contours, but it doesn't give me everything that I need. Got a picture as part of my data set for it. That's useful. I've got a bunch of data there, which I can use, ANR, the Agency of Natural Resources can use as well. But that's not going to help me right now in the moment. I'm worried about what's going to happen if the thing goes. So there it is, kind of set back. Now I'm beginning to see, whoa, I see the contours. There's the reservoir. I see the lowlands. I see where that water is going to go. And I'm thinking, this is potentially a bad scenario. But I want to look at the inundation area specifically. So take a look at that. That right there should be pretty scary. So if that dam goes, that's where the water is going to hit. So let's drill down a little bit more. Now I'm looking at facilities, other types of facilities that I have plotted. So the dam lets go, it comes down. The red area here is my, my inundation area. Take a look at what that affects. From a transportation perspective, if nothing else, from a transportation perspective. 89, Route 100, and the rail line that goes through it. So that's pretty nasty stuff. But also I can plot, because I have, again, being a prudent emergency manager, I can plot key facilities in Waterbury, overlay that, and what do I see? There's the fire station. That's where their EMS and their fire capability happens. So the dam hasn't let go yet, but I know that if it did, that's going to happen. Now can you see how I'm beginning to think about making tactical moves on the ground to anticipate that thing failing? So just what do you think? What kind of moves would you make tactically? The thing hasn't failed yet. You're still whole. You're still good to go. What kinds of things might you do taking a look just at that data?
Evacuation planning?
Evacuation planning. And hopefully you have an evacuation plan that's part of the Waterbury, in this case, Waterbury Local Emergency Operations Plan. So you're starting to think about that and how to transport those people and to where, sir?
Your operations center will hightail it out of there.
Yeah. You're thinking COOP, right? You're thinking COOP, continuum of operations. Yeah, this is the biggest irony, like in the friggin' world.
Sorry.
No, yeah. Thank you for bringing that up. No, but that's it. And so yes, but the SEOC is in the middle of this map. So what do we have to do? We have to COOP it. We have a contingency plan. We have a continuity of operations plan. So we will move all of our SEOC functionality up to Camp Johnson is where we go, and we exercise that. How about that?
The gas station or fire station?
Fire station, I'm sorry, fire station. Actually, both, but.
You might want to have a backup fire station. I don't know, it would probably be a lot to move it.
Or get those vehicles out, get
Yeah.
the apparatus out, get the
second fire station.
They
In
do,
the center.
yeah. So there could be mutual aid, mutual support.
Would you set up a second regional incident command center outside of that floodplain? Just have a plan for where it would go?
Yeah, because Waterbury, I think the Waterbury EOC, I'm not positive, it's either here or here, so they would have had to have cooped it anyway. And so, absolutely, especially if you're doing evacuation planning, that's going to take some nuts and bolts like grunt work to get that done.
And the state has an alternate site already for the SEOC.
Yeah, it's the Camp Johnson. It's pharmacy. Is that an issue, do you think? What does that make you think of?
Medical needs.
Yeah, medical needs for people that can't, older folks that aren't mobile. We ran into this in Irene. We just, we moved to Vermont 10 days before Irene hit. We lived in England for 9 years before this, and we moved here, and then Irene hit in 10 days. 10 days after we got here, we were still in boxes and everything, and I didn't really know the lay of the land, but I got to know our fire chief quite a bit after that, and he told me that one of the things that they did once things started to settle down a bit in town was they took four-wheelers and they actually had to, Rochester was hit really, really hard up over the mountain, and they actually had to deliver medical supplies, insulin and things like that to people that were just absolutely stranded. So yes, you're thinking about pharmacy, drugs, how do you get drugs to people that need them? That should be part of your local emergency operation plan. Green Mountain Coffee Roasters, it may not seem like a huge thing, but it's kind of a huge thing economically. Anyway, these guys would probably be paralyzed. Amtrak, as I said, that's passenger, but they do freight on there as well. Gas stations, when gas stations flood, that can be pretty bad environmentally. So you start to think of a lot of different ways, but do you see how conducting this analysis in a visual modality is kind of just better than talking about it? I hope that you see that. And this is another one. I put this in for you guys just because it had some more road stuff in it. But it gives you kind of a step back. And then this one, which gets to Jim's point earlier on, we can actually look and get a feel for the actual numbers of residences that we need to do something about. So in this case, there's about 630, and from there we can do transportation planning and alternative site planning and all of that.
What's the approximate depth of that inundation? And obviously it would depend on how much rainfall there'd been and how high the water level was, but broadly.
I don't know. It's so variable. It has to do with the amount of rainfall, how much the water or the ground has already soaked up, how much was in the reservoir in the first place. Less at the edges, obviously, deeper in the middle, but I don't know that there's a median.
Do you have a second layer or third layer of that? Because, so the immediate threat with a flood, but the infrastructure, the connectivity, or the lack of connectivity in that infrastructure will affect many other pieces of infrastructure and people that aren't immediately affected. Right. You're going to have isolated town or isolated road segments, all sorts of things.
Are you talking about, so stepping back, can we overlay other pieces of critical infrastructure data layers?
But we would be considering that as well in this scenario.
Yes, and that's all part of kind of the grand plan, because I actually had these maps custom built for this. This isn't anything that right now we can snap our fingers and do, but this is part of what we ought to do, we want to do as part of the CI architecture, the CI program in general. It just makes sense. We can do it with some things. We do have a lot of really good GIS stuff. Actually, dams are fairly well plotted, but to be able to do this level of detail analysis for every high hazard dam, for example, we're not there yet. I mean, that's part of the thing. We want to push it to get there because it makes sense to do that. But we certainly have some work to do to get there. So here we actually see residences. We can talk more about evacuation. We also have a capability, which I forgot to bring the website, I'm sorry, but we also have the capabilities called VT Alert. Is anybody signed up? I know you probably are signed up for VT Alert. VT Alert is a capability that will allow a local emergency manager to define a geographic area and have control of actually sending a message to people's smartphones, emails, beepers, Xboxes and PlayStations to get the word out to say imminent dam failure. We just got the word. We think we have 2 hours. You need to get out, and they can define that geographic area, and that's done at the local level. So that's pretty cool, actually. So that's that. I want to wrap it up with just talking about the key challenges, and I think I've hit most of these already. So one is the scope of the thing. It's 16 sectors, tons of moving parts in each of those sectors, and it's just a lot to get one's arms around. Defining what critical means, that's the definition of what those thresholds are for each of the sectors. That can get kind of dicey. Making the list, once we have defined what's critical and we have a list of the actual state list of what our critical infrastructure is, which we don't have yet. We have different versions of lists, but we don't have the list yet. Making it operationally useful, which I take as doing that kind of work that I just showed you. So making it useful in an operational center context, so we can actually use it to make tactical decisions. Assessing risk using the risk as a function of consequence, vulnerability, and threat, and then taking steps to actually mitigate risk. Let me go back to this one real quick and just end on something that I brought up before about modeling and simulation. So one of the things that I think I want to find more resources to help us do is actual modeling and simulations, because risk, threat, vulnerability, and consequence, modeling consequences when you're dealing with systems like these that I'm talking about, it takes some serious data and some serious computing power, and we're very, very limited as to what we can do with that right now, as far as I can tell in the state. And that's sort of why I had mentioned wanting to talk with those guys upstairs, because I know that the complexity guys have done work on the power grids, for example, and I'm just wondering if there are any kind of synergies to be found there. I don't know. That's it. I felt like I kind of talked quickly and spewed out a lot of information. Are there questions?
Who's that?
That is the ugliest philosopher that ever lived, by the name of Socrates. Jim.
So, from what I've gathered of what your office has been having to do in the last few years is on the one hand, creating these connections between either agencies that, as we all know, typically don't talk to one another, or individuals and local people, or even just assigning an individual like an incident commander. So on the one hand, it's this sort of, hey, you talk to this person and let's create a plan where we know everyone's, how to contact this person 24 hours and things like that. And on the other hand, it's, as you mentioned, it's about data.
Mm-hmm.
And the challenges of collecting data, particularly, which I'm interested to see what kind of success you have with, like you alluded to, a pharmacy, like a private sector entity. If they don't have a really good incentive for handing over the drugs, you're kind of stuck. Whereas telling a fire station that they should have a plan to move is they're going to be right on board.
Right.
So I'm wondering where you see the progress of on the one hand creating that communications system and that network plan, and on the other hand the data and the modeling and analysis.
Okay, so two parts to that, the plans and then the data piece, right?
Yeah.
So the plans, the actual planning protocols, they're in place. Every town is required to do a, once every 3 years, update their LEOP, which is their local emergency operation plan.
Yeah.
And when they do that, it's a very formatted, templated thing. So where is your EOC? Where is your alternate EOC? How do you intend to, you don't have to list people by name, but you have to have a plan for how to identify people that are people in need, people that are not necessarily mobile. For example, key pieces of infrastructure in your own town, key businesses in your own town, and how they could affect and what they've actually offered to do, if they've offered to help in the case of an emergency. All of that stuff goes into the LEOP. So the planning piece of this is certainly not ideal, but it's there. And at least there's a framework for doing it. And the template, it's decent. You think it's decent?
Yeah, the newest iterations actually,
yeah.
It's very robust compared to what it is, and it's a working document, so I think that the goal is to make it better and better.
Yeah.
Which I kind of have a question, just because I'm
going to get to your data.
It was something that, I think it'll also pertain to that, in that Jim, I think, hit it pretty solidly on the head, that private sector, there's not necessarily anything that forces them, even the most kind of secretive state information, we could go to the governor and say, make them tell us this. But with the private sector, how do you have a plan in place to kind of maybe capture that? I know communications, a lot of that stuff, they have their emergency management people on their staff that can help with that. But the mom and pop shops, I know, for instance, Georgia Market is our market in our town. That's where we get food, and that's where I get my microbrews. But if that goes down, there's not really anything close by, and if we're stranded in Georgia for some reason, maybe knowing what they have on, on hand for staff and food and stuff is important. But
we can't compel that. That's going to be that particular scenario. Working with the Georgia Village Market is going to be an in the town networking kind of thing. The answer to your question is, all right, so let me hit the private owner operator thing. You're absolutely right. We can't compel them to do anything. So we have to give them an incentive, the private owner operators, to work with us. And it's really all about relationship building. And so we talked about going to the VIC before, visiting the intelligence center.
Yeah, that's what I felt. That's what we were doing. We were making sure they knew who we were and we knew who they were.
So I'm working with them on developing sort of a relationship strategy, because I want to be able to give private industry something from the state. Not money or here, give us we need your information, so there's $1 million. Not anything like that, but prudent things in the context of CI, like cyber alerts. So we get information of all sorts of different cyber alerts that come in from different places. It's not hard to, and it's not classified. it's not hard to turn that around, put a VIC stamp on it, and send it to whatever sector it pertains to, and just say, this is one of the services that we want to provide to you.
Right.
And offer to go and give trainings. It's all about relationship building,
Right.
precisely because we can't do that kind of stuff. So I guess that's
you do have things you can offer them.
Yeah, yeah. I mean,
Yeah.
I'm not convinced. I think there are some challenges there, because I think that probably we need their information more than they need whatever it is that we at this time can give them. And so we need
Yeah.
to think harder about what we're able to provide. So warning is another thing that we see ourselves as providing to everybody, state entities and private owner operators. So if we have some kind of a discrete, or not a discrete, but a specific threat from some external actor, we want to be able to share that and warn people. So that's something that we feel like we can be value added to them about. But that's how we have to do it. It has to be all about relationship building, putting sector-specific groups together. Once this thing gets to be a bit more mature, probably 50 years from now. I'm just kidding. But once it gets to be more mature, what I foresee happening are maybe sector-specific get-togethers, information sharing,
Right.
threat and risk mitigation tactics and techniques sharing in a conference, in a room, getting people talking to one another. That's a value that we can call that, we can put that together, and that could be value added too. So it's kind of a mealy little answer to it, but you hit the nail on the head, is that there is no statutory, we cannot demand anything.
Yeah,
So we have to
because
work with that.
on the flip side,
Yeah.
which doesn't usually, which I don't think works with private sector, is their participation puts them into the mitigation planning. You know,
Yes.
like the
Yes.
more data you share,
Yes.
the more your
Yes.
interests become a part. But that's a hard thing to communicate.
It is, but I'll tell you, that worked. And for this RRAP thing,
Yeah.
yeah, right. So I went to, this is after the proposal went in,
Right.
but I went to St. Albans Cooperative and to Agrimonk.
Yeah.
And I said, hey, we're doing this thing. It's kind of a transportation ag dairy overlay, looking at vulnerability. We're looking at farm to market sort of transportation and production lines. Do you want to play? You would have access to all of this stuff, and we need access to your expertise, your subject matter expertise, to talk to us about the specifics of transportation. And they're like, I don't know exactly what this is going to be, but it sounds really, really good. We can use that product. Yeah, we'll play. So both of them are in at this point, and then if we get approved for this project, all of us, you, me, those guys will get in a room, and we're going to talk more about the specifics of the sequence. So
I'm glad you started with a private sector industry.
Yeah.
So that we'll have to get over those challenges right away.
I think so, and we'll need to be able to define for them the kinds of data that we're looking for. It's actually not us. We're not doing the research,
Right,
actually. It's the DHS modeling shop and
Right.
all of them. But, yeah, I want to get them in and on board and engaged. And if this works, so if we're accepted for the project, and if it works well, especially that private-state relationship piece, it kind of sets a precedent that we can use for other initiatives as well.
Right.
But I do want to get back to this other. There's one other hanging piece I wanted to hit on data collection. You would think that there would be some person that you could go to that could press at the state level, that you can press a button and get, here's the list of all water treatment facilities, here are the list of all the reservoirs, distribution, all of that. It's not that easy. We're Vermont, we're decentralized, there's a lot of ownership at the local level, and so there's a lot of grunt work that has to happen sort of at the county or RPC level. So that's a challenge too. So that's a piece of data collection that's not private industry, that's more municipal.
That's still hard.
I mean, and even state government stuff, which is collected and owned by the state government, is in a zillion different databases, and nobody can link them, and nobody can give you anything.
Right, and so from a GIS perspective, one of the things we're working. Do you guys work GIS with VCGI? Do you work with them? Yeah, Ivan and those. So Ivan Brown is.
Yeah, we use their products a lot.
Their products.
Yeah.
So Ivan Brown is the lead GIS guy at VCGI for emergency management related stuff, and we've just started a emergency management GIS group. which he's heading up. But this is one of the challenges that we've identified. But at the very least, at this point, we have GIS representatives from nearly all of the agencies sitting around the table to be able to kind of work this stuff out. In fact, this group, you guys might be interested in it, has invited Esri to come up next week, the 13th, to come up and give a GIS and emergency management kind of seminar for leadership. But that's one of the things that the group pushed. But yeah, we got all of those agency reps around the table, and at least we're talking about it, and there is more sharing that's going on as a result of it. ANR is a great example. ANR has some great data. We don't have immediate access to it, so we need to work those relationships and get it.
I'm thinking now about the state's effort to put together a healthcare exchange and how plagued that has been with difficulty, but essentially the state needs a lot more people who are good at setting up and managing databases so that information doesn't sit in places where it's unuseful, get updated here, and that doesn't trickle through.
Yep.
I mean, just all of it needs to be so much more tightly linked together.
I won't deny it. You're right. This is a different domain than healthcare, but it's the same principle.
It's the same
principle, same technical skills that are required. So there's the technical piece, and then another bit that we're talking about here is, yes, there's the technical database management, data access, data display, but then actually employing it in exercises so that we can start to use this data more aggressively to practice decision making using the data. So it's the actual user piece of it as well. I think we need to press there.
Yeah, that's where the models and visualizations and stuff come in.
And just tabletop exercises, tabletopping stuff. Like setting up a scenario like that, instead of me up here blathering, we actually just use it as a scenario and step through SOPs and immediate actions and what ifs and consequences, and that's useful too.
Which is something we can do through your office. That is an option, because we're actually thinking about doing it with the UAV project as well. We have SOPs that we develop, but it needs to be fleshed out. So, what are your, I guess, more transportation related? What are some of the pitfalls that you've identified? We have graduate students here who are going to be going out into the world. Are there things that maybe they can bring with them to help you in the future with this, or they can bring to their future positions?
From transportation perspective?
Yeah, what are your thoughts on just transportation in critical infrastructure and that connection?
I don't know, just some random thoughts. I really like, I don't understand all of the technical details of the network, the robustness index that you were working on before, but that whole idea where we can look at an entire network, especially roads, because when we're talking about roads, you notice I talked about critical infrastructure, and I used the word facilities, and I said, what about fences around this building? Roads, they're roads, they are the line of communication. And so how do you deal with those? How can you break road lengths into sections and find specific sections because of where they lay on the geography are more vulnerable than other sections? How do you tie that with the bridge piece of it as well? And so that's something that I'm saving transportation really and engaging with VTrans for last, because I have a lot of other stuff that I'm doing, that I'm working on right now. But it's important. Getting data about why the roads and why the rail is important. It kind of goes back to the private owner operator thing. How do we better get access to information about what is on these rail cars that are coming up, west of the Green Mountains, and where are the vulnerable points of that particular rail line? It's a huge fuel rail line. What is the most vulnerable point along that line that would do the most damage? I think about questions like that all the time. Is if I had to list a top 10 soft spot in our infrastructure, what is it that I would take out? What one thing would I take out if I were a bad guy that could have the most devastating impact throughout the state? What's the one thing? Is it a particular substation? Is it a particular step-down transformer? Is it taking out a piece of road? Is it I think about the scenario, talk about transportation, 4-step vans the I-89, I-91 nexus down in White River Junction, 4 vans, northbound, southbound, 91 and 89, explosions, take those roads out of play. How do I model and think about what impact that would have? That's not a hard operation to do. Load your vans, call a time, remote, boom, cratered, no northbound, no southbound on 91 or 89. How do I model the impact of that? I don't know an answer, but I kind of think about creepy stuff like that once in a while. Highly unlikely, high impact though.
Chris, did you have a question?
Yeah.
Well, the resiliency question too, right? So you're dealing with response and recovery questions, which is obviously incredibly important. But those scenario planning can also light the fuse to think about, well, how do we mitigate the problem in the first place, right? So how do we make sure that the dam never fails to begin with, or how do we make sure that the transportation infrastructure doesn't erode with 6 inches of rain, right? So, so to what extent do you see some movement, obviously since Irene there has been some, of integration of your response and recovery concerns with this more longer term thinking of resilient infrastructure?
So we do have, as part of our organization, a whole hazard mitigation and public assistance, mitigation and recovery branch. And is that my good side?
Yeah. You weren't facing the camera last time.
Because I didn't think I had one. So I guess the short answer to my question is yes, there's a lot of interaction. We do have the statewide hazard mitigation plan, which kind of is the best way that we have right now of going toward that. But I also know that there have been, the Vermont Center for Sustainable Living had that resiliency report.
Oh, yeah. Institute for
Sustainable Communities had that great resiliency thing, and one of the things that was in there was Peg Elmer out of South Royalton was talking about these things called CROWs, Community Resiliency Organizations, and it's one of the things that they've chosen to kind of pursue and fund. And this is looking at resiliency, not at the state level now, but at kind of the local municipal level. But at the state level, to answer your question, I think it happens at the state hazard mitigation plan level. I'm talking with Misha. I don't know if you dealt with Misha Bailey at all, but Misha writes. She sort of has overall responsibility for that, and I talk with Misha all the time, and we sort of compare notes. The thing about that is, though, that when I'm talking about this stuff, I'm really trying to talk about state level critical infrastructure. And again, gets to that threshold problem. The hazard mitigation folks downstairs, Misha and those folks, it's not just critical, it's infrastructure across the board. So as part of the state hazard mitigation plan, we're looking at all of these municipal subplans too. And I'm not looking at things below whatever that state criteria is. So I'm not looking at dams that are not high hazard dams. You had said something else though that I wanted to hit real quick. Oh, yeah, so risk, threat, vulnerability, and consequence. We already saw consequence of what happened if Waterbury Dam goes. So the material condition of these dams is in my worldview, it's a vulnerability issue. And so what I hope to be able to do as we go through and work with our partner agencies is to use whatever data that we find. If we do find, working with like Steve Bushman and ANR and all of that, that we have degraded material condition in certain high hazard dams, I would like to be able to use this in a more activist internal state way to do the right thing, whatever that is. Because I know that, and I'm not an expert on dam structural maintenance issues. I'm not an expert on any of this stuff, philosophy major. But I would like to be able to use information that we find, if it is useful, to help improve stuff like that. To use as an argument for, you know what, we need another half an FTE, or whatever it is, to look at this. I also wanted to say, in Amanda, actually, when I first met Amanda, when they invited me over here, the American Society of Civil Engineers, the Vermont chapter of the American Society of Civil Engineers has that great report card, the critical infrastructure report card. They don't cover all 16 sectors here that I've talked about, but they do cover some. And some of the things they talk about in there have to do with material condition of dams and resources allocated against those. And I would like to be able to, if we have useful information, discovered in the course of executing this program that can help do a better job and make a case for more resources against it, I think that makes sense to me to do that. Does that answer your question, sort of?
Yep.
Threat component of that equation.
Yeah, yes, that's where that would play, because that is an external thing that happens to a particular.
How would weather play into that?
It's 100% probability. It's a 1.0 probability. We had this discussion last time.
Yeah, we talked a lot about how we
yeah.
could borrow that idea of threat in the sort of probability consequence, because we do the natural disaster area, it's just two, it's the probability consequence, but I think the threat is, I don't know, I think of it as almost like a binary piece, like the threat's there or it isn't. The threat means you look at probability. If the threat, so it's almost like it takes your probability automatically to zero if there's no threat. But if there's a threat, now you have to think about the structure of the probability. So that's the way I've been sort of toying with the idea, because I like the idea of threat.
Yeah, no, because it's an important thing to consider in that whole calculus. But again, this is Vermont, and if you define threat as not just intentional actors, if it were just intentional actors, then it's a different thing. Then I can actually apply a 0.3 or a 0.2 or whatever that probability is. But this is Vermont, and threat means threat and hazard, which is meteorological. Therefore, probability 1.0, that something bad is going to happen. So I don't write it off, and I don't think it's any less important, but it's going to happen.
But the threat is not storm or no storm. Yes, we know we're going to get a storm. Right. It's a storm of a particular intensity, which has a probability.
Right, so one turns it on. We have the threat, it turns on the model. But we don't have like an earthquake. I mean, we do have.
I don't agree that it just
moderate.
But earthquake and tornado are like.
Okay, so that's not. But so we have a threat of severe flooding. We have vulnerability to a particular level of flooding, but you also need to account for how likely that is. So in Irene-type flooding, there's a lot of vulnerability, but there's also a probability associated with an Irene-type event.
100-year flood.
Right. Then there's a 50-year flood, which has a probability.
Yeah.
And
so
vulnerability to that is lower.
Those are two different models. Yeah. So I don't know. We talked about it, and I think has yet to be like the idea for threat. But I agree with you. There's a different piece than just what is the probability of that road getting destroyed by X. There's another thing.
I think that's in vulnerability. Given an X, what happens to the road is vulnerability.
Well, I don't like that term, and I want that to become a susceptible.
I think you're fighting against some established jargon that's bigger than Vermont.
It's bigger than Vermont, yeah. It's Washington, D.C.
I might be losing the jargon fight.
Socrates would probably use susceptibility. He'd like that.
Yeah, he would like to fight jargon.
That's all I got. Thank you very much for
We have one more brown bag for like the summer series, and that's going to be Chester presenting his research next week. And then there'll be a little bit of a break, and you can see the calendar for all the stuff in September. And thank you, Todd.